Back to Content Diver YouTube channel. Today our topic is designing a learning system in machine learning, and we are going to make a machine learning playlist. Please support and be subscribed and share to your friends too. Let's get started. And here we have steps for designing a learning system. Initially choosing the training experience, and then choosing target function, choosing representation of target function, and choosing function approximation, and final design. In this choosing the training experience. Before training the data, first we get the data, and then after gathering the whole data, the step we have to do is pre-processing the data. That means here we remove the dirty data, that is noisy data, etc. And the very important and first task is to choose the training data which will be given to the machine learning algorithm. We should choose the training data so that machine can be trained with that data to perform particular task. The use of training is that algorithm must have a significant impact on success or failure of a model. The success or failure will depend on two attributes here. That is, the first one is direct or indirect training experience. In this, the direct training experience and individual board states and the correct move for each board state are given. And in case of the indirect training experience, the move sequences for a game and the final result are given for a number of games. That means here it will consider the whole number of games. And the second one is teacher or not, that is supervised and unsupervised, that we have discussed already in the previous videos. If you haven't seen it, please watch it. I will keep it in description. And here the supervisor means we will have in brief. I will explain now. In supervisor means we will have a mentor, and the machine learns from a mentor. And in unsupervised there will be no mentor. The machine should learn itself. And let us consider, for example, when training data is fed to a machine, then the time accuracy is very less. But when it gains experience while playing again and again with itself or opponent, it is not only chess game, it is any type of game. Playing with the opponent or itself, the machine algorithm will get the feedback. That means it learns from its mistakes and they control the chess game accordingly. Here we consider the example of chess game. And the next one is choosing the target function. And the next one is choosing the target function. The important step here is knowledge fed to the algorithm. The machine learning will choose next move function, which will describe what type of legal move should be taken. We have many types of moves in any type of game, but we should choose one move as a target move. In checkers game, we will have red and black colors, and while moving diagonally, set of all possible moves is called legal moves. In that moves, we should select only one move, that is the target move. Then mathematically, we can do the target function, that is v of b, and the board states small b, and the legal move set, that is all set, that is number of total move set, that is capital V. Based on that, we have assigned four possibilities. That means here we have board state. Board state is the final board state, and that is 1. Means here the target function will be become 100 because it is 1, and when it is lost it will become minus 100, and it is draw. Both played well, and we finally get to know it is draw. Then we will have the target function v of b as 0, and here the b, it is a final case. Here small b is not the final state, then v of b equal to v of b dash. Here b is not the final state, so b dash is the final state. This is about the choosing the target function. And next one, choosing representation of target function. We should have a representation to choose a target function. For a, in the previous example, the board state, we can calculate the function c as a linear combination, that is c of b. Let us here, while representing a target function, we should consider the features of it. Then here, let us have the features like x1 equal to number of black pieces on the board, and x2 equal to number of red pieces on board, and x3 equal number of black kings on board, x4 number of red kings on board. In checkers game, we will have black and red pieces, and also the same as kings also, and x5 is number of black pieces threatened by red. In game, one color will be beaten by other color. So here black piece is threatened by red and x6 equal number of red pieces threatened by black. Now we should have the target function representation. This is the target function representation v equal to w naught w1 into x1b so on till the number of features that we have. Here we consider x1 to x6 and here we should the target function should have some representation, so we can consider linear equations, hierarchical graph representations, tabular forms, and many more. For example, while playing chess, machine have four possible moves, so the machine will choose the optimized move which will provide the success to it, that is choosing the representation of the target function. Choosing function approximation algorithm. To learn a target function, we need to set a training example. We need a set of training examples. Here, let us see example, black won the game. Suppose in checkers game, black won the game. That is x2 equal to 0. That means no red. In a function approximation, we need to follow two steps. That is estimating training values and the second one is adjusting the weights. These are the two steps that we follow in choosing the function approximation. In estimating training values, in every step we consider the successor. Depending on the next step of the opponent, we consider the successor, that is v train of b equal to v successor of b. And the next one is adjusting the weights. There are some algorithms. Here we should also choose the particular algorithms based on the type of data that we have and type of task that we are going to do. We will select some algorithms to find the weights of linear functions. Here we are using LMS least mean square used to minimize the error. If error equal to 0, there is no need to change anything because the error is 0. If error is positive, each weight is increased so that to minimize the error. And if error is negative, each weight is decreased. Finally, the errors are minimized. This is about the choosing function approximation algorithm. And next, final design. The final design is created at last when system goes from number of examples, failures, and successes, correct, incorrect decision, and what will be the next step. Example, here is the final design. Everything is tested before and small task is assigned and how the system, how the machine is performing, everything will be done here. And example, best example is Deep Blue is an intelligent computer which is ML based, won chess game against the chess expert Yari Kasparov, and it became the first computer which had beaten a human chess expert. This is the best example which is designed well to warn against the chess expert. Yeah, these are the steps in the designing a learning system in machine learning. And if you have any doubts, please comment down. Content Diver signing off.